Hello, everyone.
Hello.
Hi.
Hello. Hello, everyone. While we wait for everybody else to join, I'm going to flip forward to the antitrust policy notice, which prefaces all of our Linux Foundation governance meetings. If you have any questions about this policy and how it applies to you, check with your own legal counsel. If you have any questions about how we apply it, please let us know. Be useful if I actually had my headphones in. Today's meeting, I'm going to largely be talking at people. But if you do have any questions at any point during the meeting, please do let me know. We're just waiting for our executive director and our sponsor as our quorum for the day.
Are you waiting for Matt?
No, I'm waiting for Greg.
Oh, okay. Because Matt's on vacation.
Yeah, so I believe Matt is not going to be able to join us for today, but with Greg, we do at least have a 2/3 majority. So we should be okay because we have some voting stuff that we need to do today. So at least 2 out of the 3 of us should be here.
And Greg is here. Hi, Greg.
Hello, Greg. Right. I think that's all the people that we are likely to get for today. So I'm going to skip ahead and take you through the agenda. You've just seen the antitrust policy, which we usually preface. Right up front, we are going to discuss expanding the technical steering committee with an additional voting seat. Then we are going to talk through a processor command interface design proposal from Foley. And then we are going to look at audit event logging via a sidecar pattern as an extension to the system to cater for audit event logging in addition to the current system event logging. And then finally, we are going to talk about the Tazama release 2.2.0, which went out today. If you have been monitoring our Slack channels, then you will have seen all of the notifications over the last couple of days for both the release candidates as we were going through our testing process, and then also the final release that I will be showing you at the end of our meeting today. So if you're not interested in all of the other stuff, I'm very sorry. You're going to have to hang in until the end for the juicy release news. But starting off right off the bat, we would like to nominate Johannes Foley, who is currently the team lead and product owner at Cybern for fraud products, to a voting seat on the technical steering committee meeting. Here you see Foley on the camera at the top there. So Foley's pedigree, for those of you who do not know, Foley has been involved in the project almost since the beginning. So since late 2020, he oversaw the build of the minimum viable product on behalf of Cybern. And he has been instrumental all the way through since then in providing technical guidance and support for the product from a Cybern perspective. So as one of the voting members. I'd nominated Foley to this position. I think in the background we had already cleared some of our governance hurdles, but we did want to put it forward to the audience here. So Matt is not available today. We did speak with him about it. We could record his vote later, but I think as a 2/3 majority, Greg, that's you and I. So are you comfortable? Would you like to vote in support of this proposal?
Yeah, I was on mute. Yeah, I seconded it. Yeah.
Excellent. The ayes have it. Welcome, Foley, aboard as a voting member of the Technical Steering Committee meeting. I'll tell you what it means later, but for the moment, we'll let you bask in the glory. For some reason, your microphone is not coming through, so you're going to have to do something about that because you're up next. Processor command interface. This is you, Foley. So I'm going to hand over the
Right.
share.
Well,
Welcome
thank you
aboard.
very much for the nomination. I'll try do what I don't know yet what I'm going to do to the best of my ability. All right. I trust you can see my screen.
Yes.
All right. So basically, the proposal we tried to do was to introduce a configuration microservice and config hot reload via NATs. So currently in Tazama, microservices read their configuration at startup from the database and then subscribe to different NATS topics based on that static configuration. So if you do any configuration updates or changes to the network map or routing logic, that requires the restart of the microservice in order to take effect. So that means that it introduces operational friction and potential downtime. So it's a bit annoying if you're trying to change config and you have to restart your processes. This proposal introduces a config microservice that enables runtime configuration updates through NATS published events, allowing all the dependent microservices to hot reload their config without restarts. This would further require less database access and changes to the database by humans that cannot be audited and could cause confusion and problems in a production setting. So not only are we saying we can fix the production hurdles, we can also lock down the DB a bit, because right now, if you had wanted to change the network map or any config, you would need to have access to your database directly. So this would also alleviate that. A summary of the goals there is to enable dynamic configuration updates without restarting Tazama microservices. That's the thing that's bothering us. And then further, the reason why we would want to do this anyway is it would improve the operational efficiency and support live reconfiguration. Before going into implementation outline and everything else, I'd like to just go through a little picture to just explain what this would mean. So currently as a user, you will do whatever you want to do for configuration stuff, and then you'll publish that latest configuration to the config microservice. The config microservice will then save the latest configuration. That's another thing that I didn't mention, but hopefully this can also allow us to version config, because according to our documentation, we fully support versioning, but we have nothing governing that. So implementing the config microservice, we can also enforce versioning if justice allows it.
To be honest, the version control is currently built into the upcoming config UI, but will need to be propagated to the back end through the API anyway. But yes, that API should also prevent version overwriting. It should only ever be append. So yes, I'm very comfortable with that.
Great. So yes, after the config service has then received the latest config, it will save the latest config to the configuration database. And then after that, it would publish a config update event to the NATS bus. From this NATS bus, all the microservices that are subscribed to it will receive this public config update event. And all these microservices will then apply the latest config and hot reload if applicable, and cache the latest config. So that also helps us to sort out the other issue with config caching, where if config gets changed, it is possible for microservices to be missed during restarts and so forth. So this would also allow us to actually control the cache slightly better, because instead of the microservices having to figure out where their config is, they will always be dependent on the config service that will let them know.
I have a question.
Yes.
So on the NATS bus, you have a push event. Is that a push event, or is that sort of a listener that exists inside the microservices that monitors a subject inside NATS, and then if something appears on that subject, it reacts to it?
So NATS functions as a push event. So what happens is from your source, it pushes an event into the NATS bus, and then whoever is subscribed, so these microservices would be subscribed to that topic. And then since they're subscribed, NATS will know to push the event to them.
Okay, basically it's seen as a push. Okay, cool, thanks. That makes sense.
Okay, cool. So that's the high level what it looks like.
I have another question.
Yes.
Because of course I do. Could we have a endpoint specifically for the config update event? So at the moment, what it looks like is the config update event is kind of tacked onto the end of the DB update through the API. But it would be useful if we could also trigger it separately and independently. So for whatever reason, if we think a config had been misloaded or the something else had happened or whatever, we can recover by just issuing that command through its own API.
You mentioned the word API, you mean the NATS message bus?
Not the message bus. So the config microservice is an API, I'm assuming, right?
Yes, at the front, yeah.
So that API will have an endpoint that, for example, says post a rule config, or let's say post a network configuration, right? And then that post of the network configuration would have an extra step that says publish the config update event, right? Can I have an endpoint on the microservice API that just allows me to publish the config update event independently?
Yes, with other words, what you're saying is you're expecting that something else might have modified the DB and it's outside of this microservice, in which case you want to just, as a user, publish this event and then the microservices without the config because it already exists in the DB. Yeah.
Yes. But as an added sort of an extension, not to have it be a specific endpoint just for publishing a config update event, but create an endpoint that you could then give other instructions to as well, which will include publishing a config update event. So if I want to do other things to that particular processor, like for example, I don't know, restart it, refresh it, give me a health check, all of those kind of things, I could poll that endpoint on the microservice to do that work.
We can look at a list of stuff you want. Some of the things you mentioned would be possible, but telling a microservice to restart itself is not necessarily possible or shouldn't be done. But yes, we can look at what we need to do. Yes. So the way I see it, we'll go through a full design. I think this is in principle. Roland, sorry, I'll give you a chance now. But yeah, in principle, this is the high level design principle. And if we're happy with it, then we can go into the depth of like, what is this? Are we going to have different NATS topics for different types of configuration that different services subscribe to and so forth? Or do we just have one generic config channel and we can post whatever we want to that config channel, and certain microservices will just know what to do with that config and others will receive the event and disregard it. So we'll get into that nitty gritty of the actual design. I think this principle is just what I'm showing here.
Well, fair enough. I mean, that sounds great. Roland had a question.
Yeah, just I don't know, it's probably a question more for the design phase now that you mentioned that, Fody, but it's mainly around, I just want to make sure we are considering it, is that the events that's been pushed on the NATS bus there, is it just an event you say config has changed, and it's not pushing the actual config change to the microservice, just telling the microservice the config has changed, and it's for the microservice to go pull that config from the configuration DB.
Typically, our design principle has been that the DB is the source of truth, and anything that has to go via the any of the communication layers is as lean a message as possible. But then the negative part for that now is every single microservice is going to do the same call to the DB to fetch that latest config. We are using a cache first pattern, So the first microservice will fetch from the DB, write it to Redis, and ideally all the other microservices will get it from, Valkey. So all the other microservices should get it from Valkey. But what we could also look at doing is break our pattern a bit there for this specifically, since we know this one call is going to have every single microservice doing the same thing. So we could look at publishing the full event body.
To be honest, I prefer not that. I mean, I do prefer the normal approach where you're raising the event and you're telling the different microservices go fetch your latest config. Being is that number one, the microservice could be busy and it's not yet ready to actually process that cache. It needs to first finish its current instruction. So it's saying, okay, well, I need to fetch my cache, but let me finish processing, then go fetch my cache. Do you get what I mean?
Yep.
That is actually a good point. I don't know if it makes sense then to include a feedback loop, at least to say that if you are pushing something through to the database that you are then going to give people a NATS instruction to go and collect, we have to make sure that the database update is complete. So it becomes more of a sort of a
But
synchronous.
either way, it's if there's an app freak that comes down the pipeline versus having to look at it.
Yeah.
Yep.
That's a good point, Roland. And thanks, Greg.
So the advantage here is we're not too worried about speed or anything else. We'd rather make sure this happens correctly. So there is other discussions like, do we want to set up a Jetstream bus for this specifically to ensure guaranteed delivery and everything else? But we can talk about that because the problems with this idea is, as Roland mentioned, if the microservice is busy and this event comes through and maybe that microservice crashes and it restarts, it might not know that the latest config happened. So we need to make sure that whatever happens at this event, any new processor that restarts will work on the latest configuration already. So again, that's it touches on the point of saying the DB is the source of truth always.
Yeah, if we pass which microservice is being updated, the likelihood of crashing is much more limited. It's just stay in the bus and wait for the subscription to pull it out.
Yeah.
Y-
So
yeah.
the way that most of the processors work, though, is they read their configurations on demand with a read-through cache pattern. So I'm not sure if the specific scenario will necessarily be a problem here, because if the event director restarts, the event director is going to pick up the latest active network map anyway, right? Same with the topology processor and same with the TATPROC. And then the version of their own configs that they are supposed to fetch from the database are defined in the network map they receive as part of the payload. So as long as that event is updated in the database, they will receive the correct one if they restart, or as soon as they receive a network map to fetch one. The other problems may be a little bit more esoteric, I suppose. If for whatever reason the initial read of a payload or any config is corrupted, then that will be, it'll think it'll have the right version of it in memory, but it won't. But I think we're in very different problem territory then. It's not something that we'll need to fix this way. So I'm not particularly worried about somebody missing an event. It'll be a problem if they were instructed to reload like the active network map and they've missed it, because then they are going to be confused when they get instructions from their predecessor processors that says, here is the information in the network map, and they don't even know to go and read that particular rule processor's endpoint because it wasn't in the network map that they had. And that's also where it might be fair to say, well, we're picking up a problem. We actually need to retry. And I think that's, Greg, what you were talking about, is to say maybe there should be an opportunity for some sort of acknowledgement on critical services. So if
you could do that all within that. So I
Yeah.
would like to do as much work as possible for you. Yeah.
So to keep on trying to notify that processor until you receive confirmation from that processor that it had received it, that it had actually picked something off the subject. So that might be worth also just considering here is how do we force the closing of the loop for highly sensitive processes?
Yeah, this would be a good place to put Jetstream in play as well. I mean, I realize we're not worried about missing something, but on the config, we should be.
Yeah.
And we're not that worried about the speed. So that's the main reason why we disqualified
Correct. Yeah.
NATS or Jetstream for the transaction processing. But it might be worth to spin up a Jetstream process, and then we don't really have to worry about trying to handle ACKs and everything else ourselves. We can just let the tool do it. That's what it's built for. So
Yeah.
That works for me.
great. Cool. Just as a high level, the implementation outline, we'll expose an API for publishing new config. We'll process to the DB, and we'll publish to a NATS topic for argument's sake config updated. The microservices will subscribe to these NATS topic, and then upon receiving the update, they'll fetch and apply the latest config. And then they'll perform a safe atomic hot reload. Which preserves existing processing state if possible. So if you are in the middle of production and for some reason you decide you want to hot reload, we should just make sure that your current process finishes before you apply the hot reload.
Quick question. The current functionality to load that config, is that in the FRMS COE startup lib?
Yes.
So part of the startup factory. So it'll probably have to come out of that into something that is separately accessible.
It will stay there. We'll just also expose it via
Pull it
something
again.
else. Yeah.
Okay.
So initially we had it slightly differently, and then we moved it all to central to make everything so that all your processes don't have to worry about it. And that works well. I don't think we'll have to change that. If a new processor starts up or it's automatically scaled up, it needs to fetch its latest config, whatever, on startup. But then for this functionality, it will expose that same functionality via a different call to the lib. All right, the benefits: no more service restarts for config changes. Yay! We'll enable near zero downtime operations. So we should be able to do everything without affecting any environments.
Just to pause there quickly, Foley. From my perspective, that is a big benefit and probably the most important one, those first two. Because at the moment, we expect that people want to be able to calibrate their configurations in real time, and we don't want people to have to go through any kind of system downtime to be able to do this. So this is huge. I think this is an extremely important change feature.
And then on that point of important stuff, this number 4 is also very important for me. So we don't need to have a DP API required. With other words, our Postgres, we can deploy pure Postgres, and we don't have to expose an API at all, because no one should touch the DB. Again, it goes to auditing. Up here, I mentioned anything happens directly in the DB. We can't audit it. If someone decides to override a network map with something new, excluding a rule, our fraud system will not pick up fraud anymore. So that's not ideal.
No.
And then yes, this is one of the things why I got the design was we're also doing some stuff on the side, trying to do dynamic rule management, and this simplifies the future automation and dynamic rule management. So if for some reason you might want to have 2 separate transactions running and behaving slightly differently, there might be a way to do that. All right, other possible uses, I just mentioned version controlling again. And what's also very important is we might be able to use the similar pattern to see transaction history. In one case is when we're trying to do unit tests. That's quite annoying. So this would help ease that. And we can also use that to see it for first time use. So when you deploy Tazama and you want to get transaction history into the platform of your last year's worth of production data, currently it's not possible. So we might be able to get like a seeding endpoint for our transaction histories to automatically do that. Yeah,
Explain
that's
that
it.
a little bit more, can you, please? That one I would like to understand, 'cause we have a couple of people with that issue right now.
So when most of our rules work on behavior, right? And that behavior requires transaction
Yeah.
history in order to function. But right
Yeah.
now, Tazama there's no means of getting transaction history into the platform other than starting to run it and getting real-time transactions in, and that way the rules build their history. So
Yeah.
with this API, we can also expose the endpoint to say, let's upload a file of transaction histories or something like that to populate our transaction history.
Okay. All right.
Or almost like batch.
Yeah. That's
That-
kind of where I was going, is this batch mode, basically.
Yeah.
Yeah.
That would be great. That would be really useful.
Yep. And that's what I had. Any more questions from anyone else?
Not from me.
I had one question, Johan. Can I
Sam.
ask? Yeah, so this is depicted as if it's for the updates, but is this how it's going to be for the initial deployment as well?
Initial deployment, so how all of the processes work is when they start up, they read their config from the DB, right? So on initial deployment, this isn't really it's not going to really help with that. I say that, but I'm already thinking of means of using that. But yes, we don't really have a problem right now with initial startup. The main problem is when you've already deployed your own environment, but now you're deploying a new network map, then you need to ask your DevOps engineer to manually go restart all of your processes in the platform so that the microservices can fetch their latest config from the DB.
Yeah, I think that way there would be a uniform way of pushing the config to microservices. Otherwise, there would be two.
Yep.
Also, maybe a little bit of insight. So when we originally built Tazama, before we had NATs, all of our processors had a little REST API in front of them. And the idea was always that it would be then very easy to expand those little APIs to create a command interface into the processors. But then we removed the REST API and replaced it with NATs, and we kind of lost that ability to communicate with any of our processors. So for me, this is not just about the configuration load, but it's about creating an administration or a command interface channel into every processor, and then you can do a whole lot of other stuff with it. So any use case that you can consider that you would like to be able to engage with a particular processor for whatever reason, we now have a mechanism in place that we can do that. And for me, that's almost like, that's very exciting. This is a great initial use case because it solves an immediate problem that we had, but it creates infrastructure and pipeline here that we can add to in the future.
A good example of exactly what you're saying there, just is for a DR situation. So if you have a database and you have a database DR, and now your DB is on the other database, currently your processes, it's impossible to set that. So we can expose all of our environment variable config. We can finally get the vault, and we can finally use something, and then we can let the processes know this is the new DB. And then even in DR situations, you can have an active environment.
Yeah. I mean, even if you wanted to sort of do like partial migration of parts of your infrastructure during an upgrade, right? You can do that. I think the opportunities here for being able to actually administratively control the minutiae of your platform directly is very, very exciting.
I started small. I didn't want to throw the whole load in one ticket, but yes, it's coming.
Yeah, let's start here. I'm comfortable with this. I was like, as a, do we need to take a vote? How do we want to proceed with this, Greg? I mean, I'm comfortable that this is something that we need to do. I think we've even had this in our product strategy guide anyway, so this is something that we are
I'm
definitely excited
comfortable
for.
as well. Um,
So I would say let's go forward with this. Let's see where it ends up. I'm happy with it.
Out of
Right.
curiosity, can I ask one more follow-up question?
Mm.
Justice and Johan. So is the full config set or everything in configuration, is it possible to have these services hot reload for every one of those? Is there nothing that needs like, for example, has dependencies in other services? So for lack of a better word, needing some downtime?
So there is different config in a microservice. One thing is they need to know which NATS topics to subscribe to and which ones to publish to. The microservices needs to know where the DB is at any given moment. And those are the main things. There are some other technical stuff like they need to know what type of rule they are and which version they're running on and so forth. But the main things is they need to connect to these different other services. And that is why it's in the startup functionality of the microservices currently, because we're saying that type of stuff doesn't really change. So I think that was the premise for why we built it that way initially. But in theory, I cannot think of anything that cannot really do a hot reload. And when I say hot reload, it's not necessarily that the process is going to trigger the whole startup again. It's going to just reload whatever is the applicable config. So if it's being told this is a new DB, it can do that. If it needs to know I need to listen to a new NATS event, it can do that. So hot reload, I'm not saying it's going to restart. I'm rather meaning they're going to do what is applicable based on the config they've received.
Yeah. So they will reload the configuration into their internal cache, and they will resubscribe to all of the NAT subjects as per that new configuration. That's
If
essentially
required.
what's going to happen here. Yeah. As far as modularity is concerned, we generally try to keep the system. All of these processors are fully isolated and fully abstracted. But as Foley mentioned, we have 3 core services that are effectively shared, and those are Valkey, the database, and then also NATS itself. Aside from those, everything that a processor needs is baked into the processor. So there's very little dependencies between the processors. Obviously, the processors are forward chaining, so a later processor does take its input from an earlier processor's output. But I suppose that's just the way that the system has been designed. So aside from the forward chaining aspect of it, there's no other dependencies between the processors.
Thank you.
Thanks,
Cool.
Sam. Good question. Can you think of an example of where
Thanks,
that
Sam.
would be a problem for maybe your environment, Mojaloop?
Yeah, in Mojo, because some of these, the reason I asked is because we cannot hot reload because there are multiple services that have to be updated. So that was the reason I was asking. For example, let's say settlement models or currency supported. There is not that's not something that we can update in config for at a service level. So that's the reason behind that. But thank you.
And that makes sense. So you need a sort of atomicity, or everything should update all at once, not partial.
Yeah, at least a few of the core services. Yes, thank you.
Yeah, that makes sense. Now, we don't really have problems like that. I think we should be fine. There could be very strange scenarios when you publish a network map and a topology hasn't yet found the latest network map, and then the topology is not listening to the events from this rule processor, or might not even know it exists because it hasn't fetched its config yet. So there could be those type of issues. But I also don't think there is a good way to do that, but that means that you're going to have to say the environment stops. You put a stop in at the TMS API, and then you have to wait for all of your processes to say they've applied the latest config, and then allow your TMS API to carry on. So that would be in a way to get atomicity as part of the platform, which we could look at if we think that's going to be required. But that might make some sense. But then we still have some downtime, but it's going to be obviously a lot less than anything manual. So
But
Good
for
point.
me, the opportunity that you have here is you can actually now create monitoring processes that evaluates the system's integrity, and then can use this command interface to take sort of precise action, right? So if it realizes that a particular typology processor or a topology hadn't been loaded, then it can give an instruction to go and fetch it, for example. I mean, that example doesn't feel like it's necessarily something that could happen, but anything could be then monitored and then mitigated or mediated through the system immediately through this command interface. I think there's great opportunities here. And it's likely that we will continue to then grow the functionality as we keep on encountering situations with our customers where they say, we'd like to be able to do this to a processor. Again, here is the rail to do it. Somebody could just build that command into the processor in the future. I'm very happy about that. Thank you very much. Cool. Thanks, Vali.
Right.
Let's do it.
Happy to hear. Thank you very much. By the way, this
Alrighty.
also helps a bit with the Postgres implementation because there is
Sure.
no. So I'm
There's
glad
no-
everyone agrees. It's a good idea.
Yeah. That's the thing. Postgres didn't come with a DB API. We're either going to have to go and fetch one, or we are going to have to properly abstract all of our database interaction into APIs. And I'm very happy that we're doing that. So
I
yay.
do not want that DP API. I don't want to have to do with that. So very
No.
happy that you don't have that.
Yeah, no, I'm also very happy, delighted, in fact. Thanks, Wally. Appreciate it. Right. And then carrying on, audit logging via sidecar. I'm going to go through the current state fairly quickly because I would like to just move on, and we are getting. I want to leave at least a little bit of time for the system update at the end. At the moment, we have built a event sidecar pattern into the system. So there's an event sidecar that is imported into every processor that allows the processor to log system events via the sidecar to a NATS subject. And then we have an external system called Lumberjack that handles the logging. So Lumberjack picks up messages from that NATS subject and then publishes those messages to Elastic, and we can then view them inside Kibana. Is Kibana? I don't remember, but it's in the Elk stack then, right? So when we want to do system event logging, this is fine, and we can deploy this or not deploy this as we require it for a particular implementation. There are shortcuts to be able to do console logging if you're a developer. So this little subsystem works fairly well, although heads up for the future. Greg is already looking at the LGTM stack to maybe see if we can improve the logging here and also remove our reliance on Elk, which is still technically in the BSL license space. But it's something that we might come back to the TSC with in the future. So that is an aside. So this entire logging subsystem functions at the moment. We did have some issues with its performance during our performance benchmarking because we were generating so many system events during the performance benchmarking. We were basically overwhelming our capability to scale this particular component. So we had to dial back what we were actually system event logging. When we are talking about audit logging, though, we do have a number of other challenges here. So Elk storage at the moment, the way it is set up, is impermanent, right? So it does not retain all of the logs and the information that it captures indefinitely. Those logs typically last as long as the system is running. I suppose there are ways to make that a little bit more enduring, but I don't think Elk is designed specifically for persistent, immutable, long-term permanence as you would need for a auditing subsystem. Right now, the Elk stack is somewhat optional and mostly developer focused. So we handle our debug and our trace logging and everything else, system event logging. Do things start up okay? Are things happening during the system okay? And it does not perform very well under high load. So we don't necessarily want to reuse the existing sidecar to give it a second purpose, which is then audit logging, which has far higher requirements for stability and security and also for permanence and immutability. So what we would like to do is to create a separate sidecar for audit logging in particular. So that would handle audit logging in a fit for purpose kind of way, but would essentially operate in the same way as the existing sidecar. In theory, this could probably be a branching inside the sidecar. I don't know if the load on the sidecar will be that severe under audit load in a production context. But either way, we felt like if you had your own rail for the audit, then there's nothing that's going to be able to interfere with it. And also that particular rail can then be scaled and optimized by itself so that it can provide the minimum functionality that it needs to be able to deliver audit logging to whichever downstream system needs it. So you would then have that audit logger component as an NPM package imported into every Tazama processor, and then you would code the instructions to deliver audit logs. Mostly what we would audit log is interactions by an entity with the system. So anywhere where a user is doing something through an API, that needs to be audit logged. Where another system is doing something directly on a system component or in the API, that should also then be audit logged. We don't expect to have to audit log every step in our internal components. Those are in the domain of system logging. But every interface itself should have traffic through that interface then audit logged. So for example, the transaction monitoring service API, the admin service API, the authentication services API, and anywhere where you are able to do interaction with the system, which hopefully in the future shouldn't be through anything other than an API anyway. All of these things should be audit logged, and then that audit information will go through the audit sidecar, publish it to NATS to the own sort of NATS topic. Now, at the moment, Lumberjack monitors the NATS topic, and Lumberjack posts all of that information into the ELK stack. So here we may want to look at sort of a secondary controller, the comptroller, which will then be an auditor process, and that will then collect all of the message traffic for the audit subsystem and then push that into, for now, PostgreSQL. The intention here is we are trying to simplify our stack a little bit. So if we are moving to PostgreSQL for our operational data store, PostgreSQL can also function as an immutable data storage facility for audit logs. So we can use the same technology. If we feel like at some point in the future there is an alternative storage mechanism, like for example, ClickView, that would be better for our purposes, the abstraction here allows us to send that then to anywhere we like. So you would then just point your comptroller to a audit-specific database, and in the future you would log to that database. Or even, in fact, if a customer wants to be able to integrate into their own internal audit store for this kind of information, then they can just do it here as well. Which is why I'm kind of in favor of creating a separate logger dedicated to the audit logging, rather than trying to repurpose the Lumberjack that we currently have, which handles the system event logging and is currently pointing to the ELK stack on its own anyway. And then later we would do our reporting out of Jupyter. So any auditor that requires to be able to see and view the logs that are inside our database will then be able to do that reporting through the Jupyter Lab integration, and then the data lakehouse in particular, which is what we are also building for Camisa. So that will then go into the Tazama business intelligence, analytics, and reporting stack so that we can tie it into our existing system. So I want to pause here and just double check with our community whether or not this pattern makes sense. What if everybody's opinions around creating a separate audit sidecar and a separate comptroller to actually aggregate and collect all of the logs for shipping into the database environment. Questions, anyone?
I think it makes sense. We might just do it slightly different than how the Lumberjack currently works. It might not want to batch audit events. It would write them as soon as they come. But the other thing is audits are usually idempotable. So the idea is that processing shouldn't continue while I haven't audited my previous function. So the problem with NATS and using Lumberjack is your processor might carry on and do something, and that audit event is not something might go wrong further down the process. So while this makes me happy in terms of performance, I am a bit worried that audits are usually something that you can't carry on with if something goes wrong.
So
Is
if
this a
both,
Jetstream conversation again? Sorry, Greg.
no, it's Roland, yeah.
Oh,
Oh, Roland, sorry.
It's sorry, I just want to get a view when you're referring to audits, what audits are we actually talking about? I mean, it's I just want to make sure it's not that it's like the actual log entries. I mean,
think case management, so step processes, workflow, things like that.
And we would want to audit a system's interaction with the system. So if somebody is sending us transactions, we want to know who sent it to us and did it arrive properly. Because at some point, an auditor may want proof of work, and they may want a proof of execution. So those kind of things we would need to audit log.
yeah, I'm just trying to see. Okay, so it's a proof of execution, yeah. Because if it's case management, to me it's like generally those case requests, there aren't that many of it. So that's basically I usually send those audits with a payload of that action. So the case management service actually adds in that audit. But if you're referring to, I need to show evidence that this rule executed. Okay, then I see that the sidecar will be needed because you
Yeah.
can't. Okay, because I was just
And
trying
what
to
you
understand.
also
Yeah, that's what I was going to mention. I'm for that as well, having a separate channel for that.
Yes, Justice.
I expect that we will be auditing less information, but perhaps more detailed information. So for example, if we wanted to audit that the payload that somebody sent us was not tampered with during the course of the system, then we might want to take snapshots of that payload at various points in the system to say this payload has not been fiddled with. I don't know that we necessarily need to do that. Typically, for me, the auditing we want to do here is people are asking for things to be changed. This is what it is now. This is what they're changing it to, and this is the person who's doing it. It should usually typically be that level of detail.
There isn't. If it's that, sorry, I'm not seeing. Yeah, then I don't. Yeah, I mean you can go with a sidecar implementation. It's. Yeah, I mean I'll go with a sidecar
Can I
implementation if I expect a huge number of volumes, like yeah. But if it's just doing or it's a tracking configuration changes, it's does seem a bit of an overkill.
let me show you this as well, just to show you. So what we also want to be able to do is to centralize audit logging across this entire ecosystem. So every one of these new components that we are building will actually need the sidecar. So it's not just the Tazama transaction monitoring service and its components. It's also all of the other components across the system. So the case management system itself, the rule configuration module, the rule builder, the software development kit, the Tazama Connection Studio for the interface building, all of these components where users are interacting with the system needs to implement that sidecar so that they can ship their audit logs to the central audit store.
All right.
So the sidecar for me here is more about being able to create the initial collection mechanism for audit logs from across the system.
Okay, well, no, I follow you. And it's a bit of cross system. The only thing is obviously, as Foley mentioned, when you're doing that sidecar, you're not guaranteed, number one, you're not guaranteed that audit event's going to be saved, but you're also not guaranteed that the event that you've just done has actually been done, if you get what I mean.
Yeah.
Yes. How do we ensure that? Because ultimately, does that mean that this is a Jetstream conversation where we have write at least once and read at least once to ensure delivery?
You got to read out at that step as well. Instead of having like a sidecar list and
Yeah.
you actually read it out.
Yeah, so the sidecar will have confirmation that it was written, and the comptroller will provide confirmation that it was read, and then communicate it onwards. But obviously here somewhere you could probably still drop or lose a message, but that
Like you said, Jetstream will probably handle the communications.
we have about 10 minutes left, so I don't want to keep anybody too long. Do we need more conversation around this? Do we need to come back with this, or is this something that we can start exploring in design?
Let's come back and talk about this a little bit more.
Okay.
Happy
Let's set up a
to,
separate session for that. Yeah.
yeah, happy
Yeah.
to
And then-
join. Because,
Yeah.
but yeah, ideally, basically, how audits usually work, Justice, is you want to, in the same transaction that you do the work that you're doing, you also do the audit log. And if one of the two fails, the other one also gets reverted. So I don't do the actual work without the event or the audit, and I don't do the audit without the event.
Fair
So
enough. So that
All
you
exists
ensure that you are
within
auditing.
the transaction,
yeah,
go back.
figure out how to do
That's
that is
perfect.
what we'll come back to.
Let's talk about it. Okay, cool. We'll set up a separate session for that. Thank you very much. And then just as a final thing, Tazama 2.2.0, this is our Clear the Deck release. So we have not had a release on Tazama since December of last year, which is quite a long time for the system to have gone without a release. I'm going to add something here to the list of things that we did because we did them and we should talk about them. I almost forgot. Right. So what this release is intended to do is to set up the system for the next batch of development that is coming now, which is going to be a large number of breaking changes. So in particular, multi-tenancy is a release which will change the way that we approach segregation of data in the system, which is probably by itself going to result in us releasing Tazama 3.0.0. And then on top of that, we are also making a change to the core database. So we are replacing ArangoDB with PostgreSQL, which we had discussed in the past. That change will also result in a Tazama 3.0. So what we wanted to do is before we made the transition into that next iteration of the system, we wanted to wrap up and clear up all of the functionality that we had been working on over the last 8 months, publish that as a release 2.2.0 to clear the deck ahead of 3.0, which will then include all of the additional new functionality and then set us up for the Camisa implementation. So just in summary, the changes that we are looking for here, we have implemented or perfected, I would say, our abstraction for authentication services. So you can now have Keycloak, and then you can build whatever other integration into your own identity and access management that you like as a plugin without having to update the Tazama component. So both for the authentication services ecosystem and then also for the relay services ecosystems, you can extend those ecosystems with your own plugins without having to push Tazama code. So there's a clear separation between these plugins and the Tazama core ecosystem, and that will also hopefully save us a little bit of CI/CD and design work in the future. On the relay server side, as you know, we already had plugins for NATS, Kafka, Rabbit, and now also REST API. REST API is now an authenticated service, so you can use password and user authentication to be able to connect to an authenticated API. And then whatever else you want. So if you want to build your own integration, I know that we had a Google Buckets implementation that we had started with the previous pattern of the relay service. I would hope that somebody at some point would also move that across to this plugin pattern. But Google Buckets or any other kind of integration mechanism, you can then add to the relay services without making any changes. We've also made an update to the demo UI. You may recall, if you have been exploring the system over the last 8 months, the implementation of the demo UI targeted Tazama 2.1 of the system, or 2.0.0 of the system. But when we deployed 2.1, we implemented some additional features that broke the demo UI. So if you wanted to use the demo UI, you had to point it to a different version of Tazama to be able to do that. So we have now aligned the demo UI with the current version of Tazama, which is now also 2.2.0. So you can deploy all of these components at the same time. And you will be on the latest version of everything. We have also spent significant effort in clearing all of our Dependabot alerts. Please don't look if they are all gone because they're all back again. It is the nature of Dependabot that they don't disappear for long ever. It's a perpetual game of whack-a-mole. So we have implemented all of the Dependabot alerts for moderate and high severity incidents have been cleared. We will be routinely clearing those with every release going forward again as well. It was just a lot of work now because we hadn't done it for such a long time. And then just a note on our current CI/CD process. We've automated some of our processes now. So if you had a look at or if you're subscribed to our Tazama project notifications channel on Slack, you would have seen all of these notifications come through now. So initially, as part of our testing process, whenever we push code into the dev branch, we automatically publish a release candidate image to Docker Hub so that we can do testing based on that compiled image. And now for the release, when we publish code or merge code into the main branch, we are automatically publishing a release image to Docker Hub as well. So you are able to then build and deploy the system out of Docker Hub directly. So just a quick show and tell here. When you have the Tazama full stack Docker Tazama repo cloned down, there's a script file that creates you a little bit of a menu here. So inside this menu, you have a number of different options. So for example, you can deploy off GitHub. If you are a developer, you can still deploy your containers and for a specific branch directly off GitHub. But if you are just somebody who wants to spin up the platform to be able to check it out, we want to make this as easy as possible for you. So if you want some options for a public deployment of Docker Hub, that would be option 3, and you can deploy the authentication services. You can deploy the basic logging, which logs things out to a console so that you can see what is happening in the system. You can also deploy the full logging subsystem, which is then elastic, and also the application performance or monitoring, process monitoring. You can deploy the demo user interface. You can deploy relay services to be able to test those relay egress points out. Currently, it is NATS to NATS via the NATS utility. And you can build the version of the system with all these components, or you could simply build a, let me do that again. An option 2, full service Docker Hub, which deploys all of the rule processors and core Tazama components from Docker Hub, along with the demo UI, to your local system. I'm not frozen. It's stopping all of my current containers. This is probably the slowest part of the whole process. I'll carry on talking while this happens. And then also we have updated the demo UI itself. So you'll see version 2.2.0 here. This is probably going to go down in a second because I'm rebuilding all of my containers. Currently running this. Oh, there we go. I shouldn't have alt-tabbed away because you missed how quickly this all happened. So one of the things that is a little bit challenging for us, because the system does draw down and compile a large number of containers, sometimes for people who are not in the primary regions where Docker Hub has its servers, it is sometimes a little bit challenging to get the containers down. It is useful if you pre-pull all of these containers separately and then run the Docker Compose functionality on top of that, which I've done here. So that's why it was a little bit quicker. But now all of these containers should be up and running inside Docker Hub. You can see them all here. And if I just do a refresh, let's reload this page quickly. This is Tazama Demo UI version 2.2.0 reloaded off my container. And proof of the pudding. There we go. End-to-end transaction running through the demo UI, fully deployed out of Docker Hub into my local machine, and up and running with pretty much exactly 2 instructions, which I'm very happy about. So thank you very much to the team who helped with the release. Appreciate the effort. It's been a lot of work over the last couple of weeks to get the release packaged and everything properly automated and the QA done and tested. So thank you very much to everybody who helped. And that's the end of our session today. So thank you very much, everyone. I felt like this was probably our most productive and busy technical steering committee meeting in a while. So quite a full agenda. I'm glad we managed to make it all the way through it. And thanks everyone for coming, and congratulations for you again.
Thank you very much. Bye, everybody.
Thanks, everyone.
Thanks, everyone. Bye-bye.
Thank you. Cheers.